Hey guys, welcome to the next project. This week I decided to go a different way, and the tool I created is actually for learning purposes, and what it does is it actually generates intentionally vulnerable C programs that can be used for training or learning how to do a vanilla EIP buffer overwrite or buffer overflow. So without further ado, I'll go ahead and demonstrate. I wrote this tool in Python. So we can see here a couple different options. Of course, verbosity. Some of you have pointed out that I add that to my tools, and again, I'll just add I enjoy having it because it makes debugging easier, and a lot of times I'm doing debugging anyway while I'm writing it, and simply converting my print debugging into verbosity is a pretty easy way to gain some value from having those statements. The next option, specific, -s. This is to use a specific vulnerable function. So there's the 5 big ones: strcpy, strncopy, strcat, sprintf, and gets. So these are all the options you have for a specific vulnerable function to use. All of them can lead to a buffer overflow. Added a random option, so when it generates code, it will pick a random one of those vulnerable functions to use. The next one, you can specify the number of stack variables. Now this isn't super important in and of itself, but what it does is it adjusts where the buffer that you're going to overflow is actually placed on the stack, so it will shift that buffer up or down, and that can just make it less predictable to exploit. So if you're writing a script or doing some machine learning or some reverse engineering, you don't have to have the same program with the same offsets all the time, and you can use the number of stack variables to help change that. Similarly, you can change the buffer size, so how much data is needed before you overflow. So that can, by default it's 16 bytes, but you can change that to any number of bytes you want. -G for generate. This is going to be a number of vulnerable programs. So let's say you want to generate 100 different vulnerable programs. You can do that with a -G flag. And lastly, -F, this outputs it to a file rather than to standard out. So let's go ahead and see an example. So we'll do strcpy specifically. We'll do the number of stack variables, we'll make it 5, and we'll let it just generate. So here we can see it output the C program. I didn't include the ability to compile it dynamically because I didn't want to have to check for if the compiler was installed, and I also didn't want to check Windows versus Linux, and that's some stuff that can be added in the future and would definitely make it easier. But if you have the GCC or Clang or anything installed, you can just compile this and should just work. I've had no issues with it so far in my testing. So here you can see what was generated. We have our includes, we have our main function, and the main function consists of all of the stack variables, and ultimately the buffer by default is named buff. So we have here, default it was 16 bytes, named buff, and we have our 5 stack variables here. It randomly picks which type of stack variable it's going to be, what the name is, and what the value is. So you don't have to worry about any of that, and all of the values are picked between 0 and 255, so you don't have to worry about sizes either. And then lastly, we have the actual vulnerable function. Here we have strcpy, where it takes the first argument and copies that into buff, but of course that will overflow if the first argument is longer than 16 bytes, and then crash shortly thereafter. So we can actually, if we write this to a file, we can actually demonstrate that it works. So we'll do the same command, we'll do -F, and we're going to call it demo. For the file name, you want to just give it the beginning of the file name, so you don't actually want to give it demo.c or anything like that. It will append the trailer, the .c file extension. So nothing came out, great. we can see we have a demo.c program. If we go ahead and compile it with GCC, we'll call it demo. Looks like it compiled just fine. We'll make it executable. Worked. So now we can execute demo, which it won't do anything. Oh, in this case it's seg-faulted because there was nothing in the first argument. So if we do demo hello, works just fine, nothing happens, it doesn't print anything to us, that's totally fine. But if we do demo and we pass it in a lot of data, we can actually see here that says stack smashing detected, terminated, aborted core dump. So we know that there was a buffer overflow. So let's go ahead and remove that one, and we'll use some of the other command options. We're going to show the options again. So let's generate a bunch of random vulnerable programs and take a look at them. So we'll go ahead and do random with -r, number of stack variables, we'll do 12, the buffer size, we'll do 128, -g, let's generate 10 of them, and then for the file name, we're going to call this demo again, and this will be the beginning of the file name. This tool will actually prepend a number to this name, and then postpend to append the file extension. So I'll show you what I mean here in just a second. So it generated all those files. If we look in our current directory, we can see demo again. It appends the underscore and the number of the file generated, and then it appends the .c file extension. So let's say you want to compile all of these. We can actually use a little bit of bash to do that for us. So we can do from 1 to 10, GCC, with the environment variable, and this will compile all of them for us. We might get some warnings if there's gets. Yep, since gets is actually deprecated and removed, it says it's dangerous, it shouldn't be used, it's an implicit declaration. It still compiles, it still is able to produce code and link code for gets. So you'll see that, that's totally fine. If you wanted to get rid of those warnings, you could add the no implicit declaration warning to the GCC compiler flags. So now if we look in our current directory, not only do we have the C files, we also have the binary files. So we can do we can actually see here all the different files. We have demo again 9, which is a 64-bit ELF, and we have the demo again 9.c, which is C source ASCII text. So we can see that it actually did compile all of those with our little bash script. So that's the tool I wrote for this week. Hope you guys enjoy it. If you were doing, research or anything where you need a lot of vulnerable programs, this might be a great start. In the future, I'd like to add more vulnerability types, use after free, double freeze, things like that have a standard structure. And then, of course, checking for compilers and automatic compilation would make it much easier as well. So hopefully this is useful to somebody, and if not, it was cool to use Python to generate C code, and of course practicing buffer overflows is always a great time. So thanks for watching. Talk again soon.